Swayam Prabha. Digital India. Educated India.
Hello everyone. Today we'll start a new topic which is composite testing and its analytical approaches. In this segment, we will first discuss a little bit on the basics of composite quickly, and then we'll discuss few manufacturing techniques, their advantages and disadvantages, and then some testing component and their analytical approach. First, let us see what is composite, because composites are engineered materials made from two or more constituent materials. Okay, it's made of two or more composite material which are significantly different in physical or chemical properties, and that when they combine produce a material with characteristics different from the individual component. That's a basic meaning of composite here. Your characteristics are entirely different from the components. Okay? And minimum there has to be two components of significantly different characteristics. And basic issue is that the constituents retain their identity. That's important. They do not dissolve or merge into each other. Okay? But they act in together. Basically, if you see here, the example of water and sugar. When we mix water with sugar, water and sugar, they are entirely different components and their physical and chemical characteristics are different. But when we mix the water and sugar, they don't keep their identity separately. So they don't retain their identities. That's why this is not composite. So they have to keep their identity and they have to act separately, but they will act in concert. They will be actually jointly active to enhance the characteristics. So normally the components can be physically identified, exhibit and interface between each other. So there has to be some clear interface between the components and they can be physically segregated. Okay. So basically composite, the application is enormous applications are there. The basic advantage of composite is that they are very strong and stiff. They can be very strong, they can be very stiff, and at the same time the weight is very high, very low, very lightweight. So ratio of strength to weight and stiffness to weight are several times greater than the normal engineering materials like steel or aluminum. So that's why nowadays the steel and aluminiums are replaced by composites in many areas. Fatigue properties are generally better than the common engineering materials. Okay. Toughness is often greater. Composite can be designed that do not corrode like steel. So that we can design a composite which is not affected by environment. It's possible to achieve combination of properties not attainable with metal. So metal has got some positive attributes and there are different negative attributes, metals, ceramics, okay, or polymers. If they are used in segregation, in alone, okay, but when we produce composite, we can get the positive attributes of individual components. So composite is a combination of two or more components that I have already mentioned. So let us say two components. One component is it's a continuous phase, which is called matrix. Another component is discontinuous phase, which is known as reinforcement. The reinforcement component is basically used to enhance the mechanical characteristics. Okay, and continuous phase means within the composite structure, the matrix will have somehow continuity. Okay, we can see here. This is matrix. These are the matrix, and here this fibers are reinforcement. We can see here the fibers are not connected. Fibers are individually present within the composite, but matrix are somehow connected throughout the system, throughout the structure. So that's why the reinforcement is called the discontinuous phase, and the reinforcement is present within the matrix, which is continuous phase. So advantages are lightweight, low price, we can reduce the price, corrosion resistant, high specific properties like specific strength, specific modulus that we can. So if you want to classify the composites based on matrix system, one is metal matrix composite. So we can classify based on what type of matrix we are using. So if we use metal as a matrix, then we will call it as metal matrix composite. When we use ceramic as a matrix, ceramic matrix composite, and in case of polymer as a matrix, it is called polymer matrix composite. And polymer matrix composite is again classified into two parts. One is thermoplastic polymer, another is thermoset polymer. So thermoset polymer, most of the applications nowadays are based on thermoset polymers. The main drawback of this type of composites are once it is made, so they cannot be reversed. Okay, but thermoplastic polymer, they can be melted and we can use repeatedly that composite. And based on reinforcement type, so reinforcement type are particle reinforced composite. When we use particle as a reinforcement, so then it's called particle reinforced composite. Then fiber reinforced composite. So when we use fiber as a reinforcement, and fiber reinforced composites are of two types: natural fiber based composite and synthetic fiber based composite. So natural fiber based composites are gradually getting popularity due to its eco-friendliness. Okay, and based on reinforcement structure, so we can have different types of reinforcement structure. One is fiber reinforced composite. So when you use reinforcement in the form of fiber, it's called fiber reinforced composite. When we use yarn or filament as a reinforcement, then it's called filament reinforced composite. And fabric reinforced composites are there when we use fabric as a reinforcement. And fabric are of different types of fabrics we can use: oven structure, non-oven, knitted and braided fabric, and also two-dimensional and three-dimensional fabrics are also used for making composites. The applications, if you can see, there are enormous applications are there, starting from household, aerospace, construction, automobiles, sports, goods, boat and ship. So there are enormous applications. This is a few applications are shown here. Now let us discuss quickly few commonly used manufacturing processes. These processes are hand layup method, then pre-preg forming, pressure molding, or we can call it as compression molding, vacuum bagging, filament winding, pultrusion, spray method, sheet molding, bulk molding, and resin transfer molding or RTM. So these are the different methods. Let us see quickly the methods. So if we see hand layup method, here the mold is there. We can have certain shape of mold, but here we cannot have intricate shape. Simple shape molds are there. Okay, and then one release film is placed on the mold. Thin film is placed on the mold so that it can, after curing, the composite can come out easily. Then gel coat, then fiberglass reinforcement. So the reinforcements are there, and after that resin is poured on it, and by hand roller the resin is actually spreaded throughout the surface. And this system, it gives quick method of measurement, methods of production of the composite. It's a easy method. So you can see advantages are there. Low cost tools are there. We can use simply by hand laying. So there is no expensive tools are used. Versatile, wide range of products can be made depending on the shape of the mold. The disadvantages are there. It's time consuming because it's open spraying. So it's a time consuming, labor intensive. So you need physical labor because it's hand laying. Long curing cycle. We cannot increase the temperature, or it's open curing, so it's long curing cycle is there. Here main disadvantage is that easy to form air bubble. So here void content may be high, and also during handling disorientation of fibers may be there. So whatever alignment, random alignment was there initially, but fiber may get disoriented, and there is a possibility of thickness variation is also there. And also inconsistency in application of resin. So after pouring in one place, so by hand it has to be laid, but there may be some inconsistency also. As I have mentioned, large void content, okay, and also as it is open, so elimination of hazardous volatile organic compounds, resin, some in the resin, some uh, hazardous volatile organic components will be there, that will eliminate, and that may be actually there may be chance of health hazard. Next is the pre-preg forming, where we have one reinforcing fibers are there in the form of roll. It's a maybe a fiber sheet form. Then it moves through a matrix, okay, in the liquid form, and after dipping it, and it moves to oven where curing takes place, and after that, that sheet is the prepreg sheet is actually kept in a then rolled, and this is a prepreg form. The advantage is there, orientation of fiber can be changed. We can keep the different orientation of fibers here. Then uniform distribution of fiber resin with low void. Here you can have lower void content. Reduced cycle time for consolidation. Consistent, because the process is standard process, is the consistent. High productivity, we can increase the speed of winding, and the disadvantages are there. As it is continuous process, so we need a large volume. So for small volume, if we want to produce small volume, this process is not the right process. So we need large volume. Limited shelf life at room temperature for thermoses before curing. So if we don't want to cure, just only if we want to store it. So here, as in a thermoset, if we want to keep in a room temperature, the thermoset matrix, they have limited shelf life. That means they may get solidify at room temperature. And for that, we need to requires refrigeration at minus 18 degrees Celsius. If we want to keep that at minus 18 degrees Celsius, that means it will be it will cost add to cost. So it requires that low temperature, so that the curing doesn't take place. Okay, there is a chance of delamination because it's only based on simply dipping. So there is a chance of delamination. Then pressure molding, which is again called compression molding. Okay, and here we have a mold. Okay, and that the material is to be molded. Okay, it's placed in between the two molds. Okay, this is the mold cavity here. Okay, and the top mold, heating and cooling system is also there, and in between there the material is placed. the compound to be molded here, and here matrix along with the reinforcing material is placed here, and it is pressed, and heating is there. Then after that, it's cooling is there, so that the composite is formed. This is the commercial instrument, and advantages are there. Wide range of shapes are possible, but not the intricate shape, complex shape. The simple shapes are possible here. Consistency. So intricate parts are here, but not very complex parts. Okay, consistency is there. Structural stability can be achieved. It's a relatively simple system, and main disadvantage is the high cost of the machine because of the mold shape. Time consuming to heat up and cool down, and curing. So to heat up to a certain temperature, it takes time, and after heating up, it has to cool down naturally. So it takes time. Expensive molds are there. So no intricate parts can be manufactured. Here, intricate parts cannot be manufactured if you want to have complex shape, because where two molds are required, a large volume of products. So now another method is vacuum bagging method. Vacuum bagging means here you can have one this mold, okay, with release agent. So here this is a mold on which the composite has to be manufactured. So where prepack layer is placed with the red, shown by the red line. This is the prepack. That means the matrix along with the reinforcing material is placed over that, and all different layers are there. Like after that, there will be a peel ply, okay, and release film. Different layers will be there. Air or resin bleed layer. So different types of layers are there, and after that, vacuum bag is here, shown by the sky blue color. Vacuum bag is there, and when the vacuum pump is started, due to this vacuum bag system, there will be a natural pressure applied on the prepack system due to the atmospheric pressure, and that will be enough to form a composite. Okay, so this is actually, this pressure is created here through the vacuum system. So maximum pressure possible here is the atmospheric pressure. So advantage is simple design. One can simply design this system. Any fiber and matrix combination can be used here, and okay with cheap mold material. There is no expensive mold required here. Better quality for the cost, as the it's a cheap system, so quality we can get at that cost. Okay, and main disadvantage is that cannot be heated up too much because of the different types of layers present, and the bleeder cloth has to be replaced frequently because it will get soaked with the matrix. Low pressure, we cannot have high pressure higher than the atmospheric pressure. 760 millimeter mercury, and slowest speed. So it requires a long time for curing, natural curing. Inconsistency is there because it's no positive pressure control. It's a negatively applied pressure due to the um, uh, vacuum created. Okay, that's why inconsistency may be there in the quality. Now, filament winding is another method where this you can see here the rovings or filaments are there, and which is passed through a resin, which is actually resin bath is there, and it is soaked with the resin, and then it is winded on this then it's wound on the one cylindrical shaped mold, and it is simply we want, and there is a traverse arrangement, simply just like a winding machine. It's a and ultimately this composite is cured on the mold. Okay, these are the system here. Individual toes are there. Fibers, fiber impregnation is taking place, and then winding is taking place here. Here, this is a traverse arrangement, and you can see here winding is going on. And after that, the curing will be there. Okay, this is the system. Now, the main advantage is that using existing textile process, we can use this existing textile where winding can be done quick, easy to handle package. Okay, it's quick. Parts can have huge size also. So we can have a small winding machine. We can use a small winding machine to form a smaller size composite, and also we can have very huge size winding machine. So there is no limit if we can actually maintain, if we can manage. So main disadvantage is that spinning speed is limited due to resin penetration, splashing, traveler speed. So we cannot have a very high winding speed due to all these reasons, because if we have very high speed, then resin penetration will be improper, splashing will take place. Okay, and traveler speed has to be also high, so that traveler speed has some limitation, so that we cannot have very high spinning speed. So curing by heat is not easy to apply. So here heating is application of heat is very difficult, curing, because of the huge size. If you can have very huge size, so the curing is little bit difficult, and mainly the problem is the shape, very limited shape. So mainly cylindrical shape is possible because it's a winding on a particular drum. Then pultrusion is there. It's a method of manufacturing continuous fiber reinforced composite profile. Basically, a continuous fiber. It has to be some. There has to be some continuous fiber, some filament form, and the manufacturing process is similar to extrusion. So, and we just pull the impregnated that matrix impregnated filament through a spinneret, and that's why we can its name comes from pultrusion, coming from pulled and extrusion, okay, through a die. So this is the system here. In a creel we have a number of rovings or filaments are present, then guide device, and this is a preheater, and then we are pulling it through the die. This is a die. Okay, Here is the system here, full production, and resin impregnation is there. After that, here at this point there will be resin impregnation. Okay, and after that, so this is the resin impregnation point, and then we are pulling through the die. So the main advantage is that automated process is possible, high speed, versatile cross-sectional shape we can manufacture, starting from circular or some square shape, any shape we can manufacture here. And it's basically different types of rods we can produce, composite rod, and continuous reinforcement. This is an advantage because of the continuous reinforcement. The strength or some mechanical characteristics we get, it's very high. And main disadvantage is that die can be easily messed up. So die may be filled with the this matrix material, and it may be cured within that die. So that is a problem here. And expensive dyes are there, and here it's only for thermoset matrix. We cannot produce any thermoplastic composite here, because it's in a viscous form. We have to pull it. Okay. And spray method is there. So here we can see, here spraying is done through the spray gun, and spraying is it's a one matrix and short fiber, very short fiber mix are sprayed over on a mold. Okay, so spray up is a traditional open mold process in which chopped fibers are. So here we cannot have continuous fiber, chopped fiber, very small chopped fibers, and thermoset resins are there, because thermoset it has to be some viscous or liquid form. Okay, and this mix is laid on a mold. So blue color is shown. It's sprayed on a mold, and on that it's consolidated, and then it's cured. This process this process dominates the composite process for many years, but gradually it's being replaced by the resin transfer mold. So initially it was there, but gradually it is being replaced. So this is the system here. So after open molding, then through the some hand roller we can make it even. So it's a continuous process. Any material can be used as a mold. So here another advantage is, if there is any error, any unevenness, so we can correct it by respraying on that. So that's the advantage. Main disadvantage is that the slow method, inconsistency will be there because of the manual nature, no control over fiber orientation, because it's the fibers are laid by only by spraying. And where the main disadvantage is that only one side is finished, because you can see, if we can see the here, so only the back side here is a finished, other side is manually shaped. Okay, and it's also environmentally unfriendly because of the open mold nature. So there may be some hazardous fumes generation. Okay, open mold spray up chopping method. It's another open mold method where chopping is taking place. Chopping takes place during the spraying. Okay, so resin, here the chopper is there. So roving sheet is coming in a green color as it's shown, and then it's chopped by the chopper. Okay, small pieces, and from other side, both the sides, the resins are sprayed on the chopped fiber, and then through the roller it is evened out. So this is a system. The chopped laminate has good conformability and is sometimes faster than hand layup. So see, this is the actual mechanized version of hand layup system. In the spray up process, the operator controls the thickness and consistency. So if we have to increase the thickness, then we can make it slower. Okay, so that is a control. Therefore, process is more operator dependent than the hand layup. So we can change the thickness also. And the sheet molding is there. You can see here glass fibers are in the sheet form, and which is actually then it is dipped into the rotary cutter is there, then it is cut, and then the doctor's box is there, and carrier film. And see, carrier film is actually this coming from both the sides, and it's actually impregnated with the resin in the doctor box, and from the bottom this is coming, the top side of this film is carrier film is actually impregnated, and from other side, which is coming from the top, say, okay, the bottom side here, if you can see, the bottom side is impregnated, and in between the cut fibers, okay, the glass fibers are sandwiched. Chopped glass fibers. Okay, advantage is that high productivity, thus inexpensive. It is consistency is there, and main disadvantage is that low volume fraction. So fiber volume fraction we cannot have achieved very high, and here it's a only board can be made. So one only sheet form we can make. We cannot make any intricate design. And bulk molding, here this is the system. Here the prepreg is there, which is a mixture of matrix and reinforcement. Then they are being extruded slowly to form a this is a mold, and it has been pushed within the mold and to form a composite. So main advantage is that highest volume fraction can be. Here we can have very high volume fraction. We can use because it's mechanically pushed inside the mold. So very high volume fraction can be achieved here. Maybe 50% we can achieve here in this system. Good mechanical properties. Finish can be applied. Insert and attachments possible. So we can have some insert attachment here. High temperature and high pressure required here. This is the disadvantage. So we need high pressure and high temperature, and random fiber orientation only there, because we cannot have some preferential direction orientation. So that's a disadvantage, and intricate part cannot be manufactured here, and only staple fiber. We cannot have continuous filament in this system. And last one is RTM, resin transfer molding, where the resin is injected on the on reinforcement in the form of say fabric or maybe some other form. We it's placed here and resin is being injected. So this is mainly for the thermoset matrix, and within this mold, so one is male mold and female mold, within between the curing takes place. Okay. So in this process, injection of resin under pressure is there into a cavity, okay, mold cavity. So RTM can be used, it's used a wide variety of tooling ranging from low cost composite mold to the temperature controlled metal mold. So different types of combinations can be incorporated here. The reinforcement is positioned inside the mold, and then mold is closed and clamped. The resin is injected, as I have mentioned. Reinforcement can be either preform or pattern cut, roll stock material. So the advantage is that their components will have good surface finish on both sides. So here, because there is a male and female molds are there, so components will be almost finished in both the sides. Selective reinforcement and accurate fiber arrangement can be achieved because before placing we can have selective direction. So we can have very high volume fraction, 65% fiber volume fraction we can achieve here. So thickness uniformity can be maintained. So we can insert the different other items that within the mold apart from the reinforcing material. Tooling cost is comparatively low. Use only low pressure injection. Low volatile emission due to closed nature of the system. So this can be automated. Ability to mold complex structure and hollow shape also in this system. Only we have to make the mold accordingly. Low void content here. Disadvantage is that waste of resin may be there due to the spill out. Okay. Curing time longer and hard for intricate parts. So intricate part manufacturing is a little bit difficult, but it's not impossible.